Hello everyone, I hope you're all doing well. My name is John, and in this video I'm going to be going over the basket analysis or association rules task in Gaio. So I have this kind of sample process set up already here. Obviously I'm mostly going to be explaining this task here, but just so you understand where the data is coming from and all of what's going on, I'm just going to explain all the tasks real quick. So it starts with a Python task. This is just random fake data for us. You can see here we have 300 customers and it's going to create 1,000 different transactions. Here we have different products like milk, bread, beer, rice, beans, shampoo, yogurt, cheese, things you might find at a grocery store or something like that. And then we have it generate our fake data here using all of these products and categories. And then finally we have it output to this table here, tmp_basket analysis. I'm not going to execute it again here just for the sake of time, but just so you understand what's going on. And here's the table. You can see we have a transaction ID, customer ID, purchase date, item, and category. Now this builder here, all it's really doing is taking the purchase date, which here you can see based on the icon is a string, and converting it to a date. So just toDate, relatively simple. Sometimes you might have errors if you just output dates using Python. So generally speaking, we will put it into a string column and then manually convert it once it becomes a Gaio table, just to avoid any errors. And if I open up this table, you can see that it's a date column now based on the icon. And finally we get into the association rules task itself. Now the association rules task can be found in the tasks menu under analytics and association rules. And for anyone that might not completely understand what this task is, it basically computes the association between two items in your data set. So maybe people that buy bread also like to buy a lot of milk or things like that. So it finds basically all of the items that have a significant enough relationship to be noted in the table. So that's something that your business can keep track of on your own. And obviously based on some of these input variables here, you'll be able to see and track different levels of relationships and things like that. So kind of getting into the task itself, we've labeled ours basket analysis. Our result table is going to be this basket_analysis table. The minimum support value is support is the probability of a specific item appearing in a transaction. And I believe this one here is talking about the support value of two items appearing together. So instead of it just being about one item, it's about the relationship between the two. And here the minimum threshold, this is the minimum confidence level. So that is a function of if this item, then how often is this other item going to appear? So you want minimum values just so your table isn't clogged up with items that might not be related, but it also might be good to play around with these values because you might find that certain items have a negative relationship. So, instead of it being like two independent values, you find actually that customers who buy item A are actually less likely to buy item B. Just interesting stuff to note. Our column ID, so this is generally our primary key for us transaction ID, just so this task knows, oh, okay, every new transaction ID is a new transaction. And for category, we're using item. Generally, this will be your product name column, so maybe it'll be called product, or like here it's item, but you might also just have an ID, so item ID, product ID, something like that. And we're just gonna click save, and we're gonna go ahead and run this task. Now let's check out the output table, and there's a lot of cool stuff going on here. So you'll see your antecedents. So the antecedent, basically what that means is it's the first item and the consequent. So the consequent, we're calculating only if the antecedent appears in a shopping cart or a specific transaction. So the consequent is the second calculated item. So you can see here bread and juice are together. How likely is it for that person to also buy shampoo? So we have the support value of the antecedent and the support value of the consequent. So this means how likely in all transactions are we going to get bread and juice, and then how likely in all transactions are we going to get shampoo. This support value is how likely if we get bread and juice are we also going to have shampoo in the same transaction. This support value is the number of transactions where bread and juice and shampoo appear in the same transaction. And the confidence level is the proportion of if someone is buying bread and juice, how often are they also going to buy shampoo in the same transaction. So this is based on those items together in all total transactions, whereas this one is those items together when specifically bread and juice are also purchased. The lift value is a value that basically determines like how much more often do these items appear than apart. So obviously a higher value means there's a more significant relationship, or can mean that there's some evidence there to prove that. The leverage value is the difference between the actual occurrences of these two products, or I guess these three products occurring, and versus what the expected values might be if there was no relationship at all, if they were completely independent. So again, you want a higher value. The conviction, again, this is about the relationship. Now, a value of 1 generally means that there's no relationship, they're completely independent. Above 1 means that there's some relationship, higher is better. But once you get into the 0 negative values, that means that they're actually reverse correlated. So you actually find less of the other item when the first item is purchased. And this here is Zhang's metric. This is another kind of confidence level basket analysis. Again, this value you want it as close to 1 as possible. That denotes the kinds of significant relationships. So we can see here, this cereal and juice, they have the highest confidence level, the highest lift, the highest leverage, the highest conviction, and the highest Zhang's metric number. So there might actually be a significant relationship here. Maybe I start advertising these products together and just experimenting, because maybe this leads to some kind of a breakthrough or something like that. But obviously this is just sample data, so not related to any kind of real life transaction information. But yeah, that concludes our video about the association rules task. Our documentation will be linked below, and as always, our customer support team is always willing to answer any questions you may have. Thank you.